Hello. So I'm gonna read an excerpt from 2600. Sorry, the best of a hacker's odyssey. So basically, I found really interesting excerpt. It's on the history of hacking. Um, so I'll read out like the main title for each paragraph, and then I'll read each paragraph out. So the first one is ringing. So to inform a subscriber of an incoming call, the telco sends 90 volts of pulsing DC down the line. In most phones, this causes a metal armature to be attracted alternately between two electromagnets, thus striking two bells. Of course, the standard bell, patented in 1878 by Thomas A. Watson, can be replaced by a more modern electronic bell or signaling device. Also, you can have lights and other similar devices in lieu or in conjunction with the bell. A simple neon light with its corresponding resistor can simply be connected between the red and green wires, usually L1 and L2, on the network box, so that it lights up on incoming calls. Be advised that 90 VDC can give quite a shock. Exercise extreme caution if you wish to further pursue these topics. Also included in the ringing circuit is a capacitor to prevent the DC current from interfering with the bell. A capacitor will pass AC and pulsing DC, whilst it will prevent straight DC from flowing by storing it. Another reason that Telsco hates black boxes is because ringing uses a lot of common control equipment in the CO, which uses a lot of electricity. Thus, the ringing generators are being tied up while a free call is being made. Usually, calls that are allowed to ring for a long period of time will be construed as suspicious. Some offices may be set up to drop a troubled card for a long period of ringing, and then a no-no detection device may be placed on the line. Incidentally, the term ring trip refers to the CO process involved to stop the AC ringing signal when the calling phone goes off hook. It is suggested that you actually dissect phones to help you better understand them, regardless of whether or not you want to build any devices. It would also help you to better understand the concepts here if you actually prove them to yourself. For example, actually taking voltage readings on your phone line. Any simple multi-tester, a must, will do. Freaking and or learning is an interactive process, not a passive one. Okay, so the next paragraph is Genesis. In the beginning, all long-distance calls were connected manually by operators, who passed on the call number verbally to other operators in series. This is because pulse, aka rotary digits, are created by causing breaks in the DC current. Since long-distance calls require routing through various switching equipment and AC voice amplifiers, pulse dialing cannot be used to send the destination number to the end local office. Eventually, the demand for faster and more efficient long-distance service caused Bell to make a multi-billion-dollar decision. They had to create a signaling system that could be used on the LD networks. Basically, they had two options. One, send all the signaling and supervisory information, i.e. on and off hook, over separate data links. This type of signaling is referred to as out-of-band signaling. Or, two, to send all the signaling information along with the conversation using tone to represent digits. This type of signaling is referred to as in-band signaling. Being the cheap bastards that they naturally are, Bell chose the latter and cheaper method, in-band signaling. They eventually regretted this though. Hee hee. Next paragraph. In-band signaling principles. When a subscriber dials a telephone number, whether in a rotary or touch tone, aka DTMF, the equipment in the CO interprets the digits and looks for a convenient trunk line to send the call on its way. In the case of a local call, it will probably be sent via an inter-office trunk. Otherwise, it will be sent to the toll office, class 4 or higher, to be processed. When trunks are not being used, There is a 2600 Hz tone on the line. Thus, to find a free trunk, the CO equipment simply checks the presence of 2600 Hz. If it doesn't find a free trunk, the customer will receive a reorder signal, or the all circuits are busy message. If it does find a free trunk, it seizes it. Removing the 2600 Hz, it then sends the called number or special routing code to the other end or toll office. The tone it uses to send this information are called multi-frequency tones. An MF, multi-frequency, tone consists of 2 tones from a set of 6 master tones, which are combined to produce 12 separate tones. You can sometimes hear these tones in the background when you make a call, but they are usually filtered out so your delicate ears cannot hear them. These are not the same as touch tones. To notify the equipment at the far end of the trunk that is about to receive routing information, the originating end first sends a key pulse tone at the end of the sending digits. The originating end then sends a start ST tone, thus to call said number. The equipment would send said number in MF tones. When the customer hangs up, 2600 Hz is once again sent to signify a disconnect to the distant end. History. In the November 1960 issue of the Bell System Technical Journal, an article entitled Signaling Systems for Control of Telephone Switching was published. This journal, which was sent to most university libraries, happened to contain the actual MF tones used in signaling. They appear as follows. Bell caught wind of blue boxing in 1961 when it caught a Washington State student using one. They originally found out about blue boxes through police raids and informants. In 1964, Bell Labs came up with scanning equipment, which recorded all suspicious calls to detect blue box usage. These units were installed in COs where major toll fraud existed. AT&T security would then listen to the tapes to see if any toll fraud was actually committed. Over 200 convictions resulted from the project. Surprisingly enough, blue boxing is not solely limited to the electronic enthusiast. AT&T has caught businessmen, film stars, college students, doctors, lawyers, high school students, and even millionaire financier Bernard Caulfield using the device. AT&T also said that nearly half of those that they catch are businessmen, and that's the ones that they catch. The use of Blue Box, one would usually make a free call to any 800 number or distant directory assistance, NPA 555-1212. This, of course, is legitimate. When the call is answered, one would then swiftly press the button that would send 2600 Hz down the line. This has the effect of making the distant CO equipment think that the call was terminated, and it leaves the trunk hanging. Now the user has about 10 seconds to enter in the telephone number he wishes to dial. In MF, that is. The CO equipment merely assumes that this came from another office, and it will happily process the call, since there are no records, except on toll fraud detection devices, of these MF tones. The user is not billed for the call. When the user hangs up, the CO equipment simply records that he hung up on a free call. So yeah, that was just a segment that I found really interesting from basically 2600. I love the futuristic vibe. I think it's great. I think we definitely need to kind of like advance as a culture. I'll find more interesting parts that like I can actually contextualize. But I did find it fascinating how kind of like real time the whole thing is. So yeah. Anyway, bye.